Thank you so much for coming out to this special Then and Now presentation. My name's Ian FailesI'm from Befores and Afters magazine. And today you're in for a bit of a treat with a look back at the history of Foundry's Nuke, all the way from when it started at Digital Domain. And we're doing that with Jonathan Egstad, who is now known as the Nuke architect at Foundry. Please welcome Jonathan.
Hello, nice to be here.
So if you happen to come to a session like this I did last year with Mark Elent, it was on Houdini. And so what I've been doing as part of these sessions is diving into a piece of software or tool that I think many of you are just in or on the box on in your careers, and we don't always sort of get a chance to dive into them. So this is going to be a look back at Nuke, but particularly, of course, with Jonathan's influence on it, including the use of the development of Nuke's 3D system. A couple of quick things. We're going to leave a lot of time for questions, so please think of your questions. Anyone who asks a question is going to receive one of my Befores and Afters magazines, so hopefully that's a good bribe. That's okay. And until they run out, of course. And yeah, ask the trickiest Nuke questions ever, right, Jonathan?
Sure. Absolutely, yes.
One cool thing that Jonathan worked on was Titanic. So there's a Titanic Nuke script that we're going to dive into, which I think is really fun. But why don't we start, Jonathan, with talking about how you even came to work at Digital Domain back in the day?
Yeah, I went to school for film and TV production, but I've actually never worked in film and TV production. I immediately went into doing video engineering. So I worked at a couple different post-production houses in Boston and then in LA, where I wanted to get into visual effects. And in 1993, I had the opportunity to get on board at Digital Domain at the very beginning, so as the video engineer. So I helped build the facility. So I installed all the video equipment, build the rooms, the editorial bays, all that kind of stuff. And then that was really the beginning. And so at the time, there was a lot of stuff going on. And then I had a chance to work in production.
And just in case people don't know, Digital Domain was this startup, is still around as a studio in different format. Startup from Scott Ross, Jim Cameron, and Stan Winston.
Yes.
And they were doing things differently, I guess, than many other visual effects studios. In terms they were kind of grungier, felt like they were at the time.
We had attitude. You know, we had a pirate flag was our mascot, so we had a pirate flag above our building. And we were all very young and stupid and energetic, and we weren't necessarily trying to send up ILM or something, but we were enthusiastic and driven to kind of do our own thing. And we had a mandate because it was Digital Domain, and the whole point of it was Jim really wanted to get into digital filmmaking or digital visual effects. And so rather than it being about us starting life as a motion control and photography and having optical printers and all that kind of thing, it was about using new digital technology to do visual effects. And that was really drove every decision that we made.
So when you arrived, what were the kinds of tools used for compositing at Digital Domain?
It was Flame. So at the time, we had the most flames, I think, in the world. We had, I think, 12 Inferno licenses. We had, I think, 8 Flame machines. We had 8 Onyxes running Flame. The Inferno part never came about because that was supposed to run on an IBM PVS, and those just didn't pan out. But we had that. We had 8 Flames. And at the time, that was a lot. But it wasn't enough.
Yeah. I do realize we're talking about 1993 here.
Yes.
It may well be before many of you were born. So, and just in case you don't know what a flame is, yes. Jonathan, what actually was that?
So a flame is a compositing package that runs on Silicon Graphics well, now it doesn't, but at the time it ran on large Silicon Graphics mainframes. So the Onyx mainframe was a full rack in height, and it had the power of your phone, not even your phone. Your phone probably has more graphics horsepower than the Onyx did. But at the time, it was the only machine that had enough real-time graphics performance to be able to do real-time compositing or that kind of image manipulation. And they were expensive. They were extremely expensive. The hardware itself was $500,000. So one machine was $500,000, and the software, Flame at the time, was $100,000 and some $1,000. So each machine was $750,000 in the end. So we had 8 of them, and that was a huge investment in money. And you could only, one person could use the Flame at a time, and you only had to, you could only process on the Flame. You couldn't send that work out to the render farm. You had to do all the processing locally. It had disk drives that were striped, so they were very fast and efficient. And they had a certain number of CPUs that weren't particularly fast. And so when you went to process, you had to wait, basically wait for the machine to finish. So it was a very serial process, and only one person could be using it at a time. And that really constricted the number of shots you could work on simultaneously.
And so I'm guessing that some of the restrictions that came from doing things on Flame led to Nuke eventually.
Yep.
But incrementally, right? There was sort of baby steps.
Yeah, so Nuke really started as this script-based command line scripting system called Nuke의. And it was written by an engineer, Phil Beffrey, who went on to Pixar a couple years later. But it allowed what was fairly typical at the time, when the CG artists are rendering things and they want to assemble them, they would run a script to assemble those pieces. And generally it was A over B with maybe some simple color corrections or blurs, and that was about it. And there was no UI, there was no graphical interface. It was simply you typing in commands into a terminal to set up a script, and you had to execute it and see if something came out the other end. So that's literally the beginning.
Right, and at that point called Nuke.
I believe so.
Right.
Some of this is lost to the
right.
mists and fog of history.
Because there's always been a bit of a mystery about what the name Nuke actually means or where it came from.
Right.
Can you shed some light on that background?
Yes. So at the time we were using Flame heavily, and so we had a relationship with Discrete Logic, who wrote Flame. And apparently there was, and I was not present at this meeting. Apparently there was a meeting that did not go well with Discrete Logic, and it really put the fire into some of the people at Digital Domain to come up with another solution. So that was really the genesis of, like, we gotta write our own compositor, we gotta make our own compositor as a tool. And from that meeting, outside that meeting, a bunch of riled up young guys were like, what are we gonna call it? What are we gonna call it? So it's gotta be bigger than Flame, bigger than Inferno. And because the term Nuke had already been used, it's like nuke. It's, what's bigger than a nuke? And it's literally that. It's, not very romantic, but.
I have to say though, over the years when I've done some interviews, some people have just said it means new compositor.
That's what I was told for many, many years.
Right.
Yes.
Okay.
Yes.
Sorry to burst the bubble of anyone who thinks that's what it was.
I actually reached out to my friends who were physically there at that meeting, and 2 of them confirmed, yes, that was the conversation. So I do have it on good authority.
Right.
Yeah.
And what were the early things that Nuke could do or couldn't do? When it was kind of in that first stages of being built?
Well, the Nuke 2 version, that first UI version, it could do basic compositing, your color corrections, your blurs, your assembly, and your transforms. And importantly, it was able to transform an image in 3D. It was able to rotate that image and put perspective. And we use that a lot to do what are called pan and tile setups. So we would take still photography from a single position, and we would then position those tiles or those images in what would be physical, the rotations. And then we could reconstruct backgrounds. So we could pan around this virtual environment. And that was used heavily on early shows like Apollo 13 and Titanic and Fifth Element and all that kind of thing. So that was really the genesis of. And the other key thing was a lot of the tools replicated Flame's functionality. So Flame's color corrector was essentially near compatible. And that was an important thing for us to do. So we could set up a comp on Flame and then do the same comp in Nuke and then render it on the render farm.
I just want to go to this frame, Jonathan. This is a couple of splash screens from Nuke over the years. And I just was thinking maybe you could talk about a few of them, including the one in the top left-hand corner.
Left, yes. That is the Nuke 2 splash screen. So it's a nuclear explosion through the word nuke. And
Very original.
And the blueprint is the blueprint for an atomic bomb.
Oh, really?
Yeah.
Oh. Wow. Do you have any idea who did that artwork at all?
It probably was Bill Spitzak.
Right.
So Bill Spitzak was the primary engineer behind it, and the Nuke 2 and Nuke 3, and really built the main engine. And he actually came from he went to USC film school. So he had an artistic background as well as being an amazing engineer. And that's one of the key things that made it successful, is he was able to take that artistic ability and apply it.
Yeah. I also love these other ones on the other side, which are slightly variations of the same thing, obviously Nuke 3 and Nuke 4. Mm-hmm. But that's an optical printer?
It is.
Imagine.
It is. Yeah. I have no idea where that came from. But that speaks, and if you look at the Nuke 2, you know, it was an in-house tool, so it's not like we were spending a lot of time trying to make these splash screens look amazing for a bunch of customers outside the company. So you can kind of see when it became a commercial piece of software, things got a little bit nicer.
A bit more pro, yeah. I mean, that's something I think everyone will realize, that Nuke came out of Digital Domain, but for a while it was only inside Digital Domain. You know, the 90s had a lot of visual effects studios making proprietary software.
Yes.
And it was kind of the killer thing that they would probably use to help bid on jobs and things. But What was that like working in Nuke, knowing that only DD had Nuke at the time?
The goal was to be more efficient with less people, not because we wanted to be cheaper, but because we didn't want to kill people. We wanted to be able to, because we had gone through a lot of hard productions. And so what it was the driving force behind it was we need to be more efficient. We need to be able to be faster so that we can get our work done faster so that we can, have lives. So that was really, from a workflow perspective, that was what we were, that motivated us.
Yes, okay. So this is really just a teaser to show you the splash screens from Nuke. As you see, as Jonathan mentioned, became a bit more pro. And then you see this name D2 software there. We'll come back to that. And then, of course, it became part of Foundry, and we'll also deal with that. But before we get there, Jonathan, I think there's a really fun thing related to Titanic that I want to go through with you. First, we'll watch this shot.
Titanic was called the ship of dreams. And it was. It really was.
Okay, actually, we're going to watch it again because I love this shot and it's important to what we're about to talk about.
Titanic was called the ship of dreams. And it was. It really was.
Okay, Jonathan, that's your shot from Titanic, right?
Yes, it is.
Tell us about compositing that and what went into it. Yeah. What are the different elements in that shot?
So one of the things that that came about was the fact that we didn't have a plate for the dock. We didn't have physical photography for the dock, even though they had physically built a Titanic full size. We didn't have a matching part of the plate on the right-hand side for a physical image. So we had a model on the left, and we had to reconstruct the physical dock on the right. So really, it's about two models on the left, which is the underwater model, motion controlled, and then the match move to the 40-foot model of the pristine Titanic, and then a lot of some CG to reconstruct the dock and the buildings and the gangplanks, and of course the people. Some of the people walking are CG, rendered, animated. But all the people on the dock, those groups of people, are photographed elements. Little green screen groups of people, like 4 or 5 people at a time. And they're replicated, and they are moved and around and rotated, and then placed on the dock.
Yeah.
Yeah.
And we've got a really rare thing here that I'm about to show that I don't think has really been shown much at all. It was in a very famous compositing book by Ron Brinkman. Hopefully, you have some compers here that might have purchased that book when it came out. But this is the Nuke 2 script for this shot, which was TT18, which I think is really cool. I think this deserves a round of applause. I'll come and sit back down. And then I'm just going to scroll through with a few closer up looks at that script. So, Jonathan, tell us a bit about what's going on in this script, if you can.
Well, it looks much like a Nuke script, right? So this is Nuke 2, and this is 1996, right? 1997. You can see that, most of the recognizable things where the images are little postage stamps, and we obviously have the standard node graph connections between the nodes. But there are a couple differences between the Nuke 2 architecture and the newer architecture, which show up. And if you look at the upper right, you'll see these long banks of rows of merge nodes. And each of the green screen pieces come down in 2 lines, and then there's a bank of them. And that was necessary because at the time we only had 4 channels. And then each, but I needed a 5th channel. I needed a 5th channel because I needed to max or min the shadows together, but I needed to have the green screen silhouettes of the actors separately as an alpha. So I needed one more channel.
Right.
And because I needed one more channel, I ended up having to duplicate all the functionality. So that shows you why, one of the reasons why there was an architecture change. And there's a lot of removal of the alpha channel, change it to a mask, and then copy the original alpha channel back in, do some more operations, copy back in.
Yeah, so I'll scroll across to some more things and go even closer in on something. This one here.
Yeah. So it looks, almost exactly the same. So you see the copy 13 and the various copies that are bringing the alphas in, changing them to masks, and then recopying the alpha. There's a lot of alpha management going on. And that just caused the script to look complex, but what was going on was relatively simple stuff, right? It's just management of the channels that was caused a lot of the topology to happen. And you'll also see the red nodes are manual buffers to make the script execute. So we used to have to do this manually. We used to learn and understand how to make the script render properly and efficiently. We used to have to manually place buffers into script for that to happen.
Right. And look, Titanic was hugely successful and, of course, won Visual Effects Oscar and many other awards. But it seems to have been the impetus at Digital Domain and where you had a huge involvement in turning Nuke into much more of a 3D system.
Yeah.
That's right, isn't it?
Yeah. So if you go back, the green screen sections, they go into these little transforms nodes. And there's a transform and a camera node. And each of the camera nodes essentially is the shot camera. So I'm trying to shoot through the shot camera. I have to transform the card. But there was no 3D system. So this was all done through coordinates. So you had to visualize in your mind, right, where the camera was in 3D space in your head. And you had to then place things. And we knew where some of the things were because we had to construct the objects, right? But you had to, there was no way you could pull out and see the scene. So if the card didn't render, you just got a black screen. You didn't know if the card was behind you, above you, below you. So you had, in your head, you had to keep the coordinates straight. That was a pain. Yeah. So, and there's a lot of clones going on because that same camera had to be used over and over and over and over and over and over again for all of these.
Yeah. And so how did it fall to you to be the person to redo Nuke and make it into a more efficient 3D system?
I was naive enough to think I could do it. So I had, what did it for me was in Titanic, we were getting to the point where, actually this is before Titanic, on Fifth Element, where Nuke 2 would sometimes be really, really slow. You would change frames. And it had to do with the complexity of the script. So a script as complex as this, it could take 30 seconds for Nuke to change frames. And because there was a fundamental bug in the way that Nuke was evaluating that graph. And it became a point where it was really affecting our day-to-day. But Bill, who had written all this and had done the architecture, he was actually working as an artist on Titanic at the time. He was compositing. Oh. So I came to him and said, my God, how can we fix this? And he said, well, here's the source code.
You do it.
If you can find out you can figure out what the bug is, I'll put it in. It's like, okay. And so I did. I had enough software experience using Modula 2 and BASIC and all that. So I knew how to do print statements. So I put print statements everywhere. I found the loop that was causing the problem and fixed it. And that, to me, was like a drug. It was like, oh my gosh, I was able to change the tool that I work on for the better and actually, change how, it was just fantastic.
Yeah.
And that's what gave me the enthusiasm and hope to do the new structure, the new design.
And there were other tools around at the time. I think DD was a heavy Prism/Houdini user.
Yeah.
And, there was a couple of other compositing tools around. Did you get inspired from what was around and include that in your new approach to Nuke?
Yeah, so at the end of Titanic, we had, all the issues we had to run into, practical problems we had to run into in production. We had pretty much pushed the Nuke 2 architecture up to its limit and probably pushed it past and, into the bottomless pit. And this is not, by the way, the biggest script. I mean, there are other scripts that we had, shots that were much larger than this. So we just learned that we needed to improve it. And at the time, we were saying we need to improve it. We needed to rewrite it. And management was like, "What do you mean? we just built it a couple of years ago." And we're like, "Yeah, well, we need to make it better." And they're like, "Okay, well, why don't you look at commercial packages, see if there's a package that'll work for you." And so we went and evaluated, Kerry Villegas and I evaluated Shake, because that was the only other really node-based system available at the time. And while it had some tools that we didn't have in Nuke, it was also a lateral move. It didn't give us more than 4 channels. It didn't give us a 3D system. It didn't give us a full floating point workflow. So there were things it wasn't enough. We were wanting to step up, not step to the side. And that was really what caused us to work on the new architecture and taking inspiration from the way Flame worked, taking inspiration from the way Houdini works, and kind of taking those things and using those as the basis for this new workflow that we were trying to do for Nuke 3.
Yeah. On top of that, kind of color pipelines were, and linear space and log space and all that kind of thing were what people were talking about in visual effects at the time, right?
Yeah.
You just shook your head.
It was a nightmare.
Why?
It kind of still is, right? It was even more of a nightmare back then. In the 90s, it was all no one really understood how to do it right. There really wasn't a Cinesite had Cineon, and they were doing log compositing, and that was certainly more powerful. But really like Flame worked in 8-bit and in video gamma. And so most houses around that time were working in fixed point, 8-bit or 16-bit video gamma. And no one was really doing a lot of high dynamic range work at the time. It was something we aspired to do, but the tools weren't there. The technology wasn't there really to do it. So that was a key part of the new system was floating point, full 32-bit floating point channels. So really there were 3 killer features that went into Nuke 3. It was 32-bit floating point, color data, a 3D system, and multiple channels, more than 4. Yeah.
Yay, more than 4. Yeah. Jonathan, what is or was your Fluke GUI?
Fluke. Oh my God.
I don't know if anyone knows about Fluke. No?
No.
Go ahead.
So one of the things about Nuke was it had this nice GUI, but we were coming from Flame, and Flame, I loved Flame. I loved using Flame. Flame is great until it's not. Like, Flame is great until a certain point, and then you realize, oh my God, I have to redo hours of work that I just did because I have to change it. I've done a bunch of painting. It's not procedural. They put more proceduralism into it, but it was still a very manual process. And so the idea was, well, how do I get like some of the niceties of the UI of Flame, but with Nuke as the processing engine underneath? And so that was the genesis of what was called Fluke, Flame and Nuke.
Right.
And it was just prototype. It didn't turn into anything. But we did have what was called Flame to Nuke, which is actually very similar. And that would convert the Flame scripts to Nuke scripts as much as it could. You couldn't do everything. And then we could execute those scripts on the farm. And this was all within a very short period of time, a couple of years, where we were searching, right, for the solution of how we were going to improve our compositing workflow. Because again, going back to Flame, we only had 8, and we were running double shifts. So I was the night shift on Apollo 13, along with Brian Grill and others who are now big people in the industry. And they all started, nighttime Flame, because we could only use the machine. And so the only way to make more, get more efficiency out of the machine was to use it 24 hours a day, virtually.
Right.
So we were searching for a way out in that, and that eventually became Nuke 3.
And what was the first project that really demonstrated what you'd done in Nuke 3? Was it Time Machine, right?
Time
With
Machine.
Guy Pearce.
2000, yeah.
Yeah.
Yeah. And that was the first time we had done a full floating point, high dynamic range compositing, except for one shot. One shot was left over from Nuke 2. And that was, but yes, the rest of the shots were full Nuke 3.
Okay, amazing.
Yeah.
Now, all of that amazing work you and the team had done culminated in a SciTech award.
Yes.
What do you remember what the exact citation was for that? I'm afraid I haven't got it in front of me.
Well, it was for Nuke 2, actually.
Oh, right. Okay.
Yeah, it was for Nuke 2. Yeah, I don't remember exactly. It was a certificate.
Yeah.
Yeah, award for Nuke 2.
What was that like, winning a SciTech award? Which is
That was
is
exciting.
an Oscar. Yeah.
It was exciting. We were just finishing up Time Machine, and myself and Sonia Bichard had just worked nearly 24 hours, finishing one of the big shots, and we were delirious and walking out after the sun had come up because we had worked all night, and somebody was running across the street with this envelope waving at us, and they're like, oh my God, and that's how I knew,
Yeah, very cool. Well, the next kind of thing that happened in the history of DD and Nuke was that although it was only an internal piece of software, proprietary piece of compositing software, DD wanted to commercialize it, right?
Yeah.
And it did that via D2 software. I know around this time you maybe left Foundry and, or a little bit later. Can you tell people a little bit, though, about how D2 worked and what that was all about?
Yeah, so D2 software, so when we went and designed the new architecture in Nuke 3, we did it with an eye towards selling it. So we architected it so that it would be easy or easier to take it out of Digital Domain and sell it as a separate product. So we had already, from that point, decided to do that. D2 Software was the internal division within Digital Domain spun up to manage selling it as a commercial product. But Digital Domain's not a software company, and it was somewhat successful, but not huge success. Because we were selling to our competitors, right? We were Digital Domain and we were competing with ILM and Sony. So there was a certain resistance to our competitors buying a product from one of their major competitors. But it was, at that time, it was this, there were early adopters. There were some early adopters, mostly in Europe, who were, brave. And I remember getting an email from someone, I think in Sweden or in Denmark, asking about the 3D system. This would have been 2003.
Right.
And I was shocked that somebody outside the company was actually using this tool. It's like, oh my God, now when I change something, I have to think about other people outside the company.
Well, that's interesting. It all sort of changed again when Foundry, or the Foundry at the time, which had been making plugins and contributing to other pieces of software, essentially productized Nuke.
Yes.
But with some interesting mechanics, right, about the way that worked.
There was so Digital Domain got sold, or was sold in 2007 or 2006. And became Digital Domain 2.0.
It's now 3.0.
I think 3.0 now, yeah. So it was 2.0, and the new owners really wanted to make another run at productizing Nuke and selling it and doing a better job. And they recognized that D2 software, being an internal Digital Domain thing, was a barrier. So the idea was, well, we will partner up. We will get a proper independent software company to take over the code base and sell it, right? And that was the idea. So Digital Domain purchased the Foundry, who was making a lot of plugins at the time, a fairly small company, with the eye towards spinning it off. And then it was only a year and a half, 2 years, where the Foundry was able to then purchase themselves away from Digital Domain and become truly independent. And at that point in time, Shake was kind of on its last legs. Apple, he was dying on the Apple vine.
Yeah, but that's interesting, isn't it? Not everyone in this room might know about that. There was Nuke and there was Shake.
Yes.
And then Apple bought Nothing Real, which made Shake.
Yes.
And end-of-lifed it, sort of. Tell us about what that was like when you heard that Apple bought Shake and what the industry conversation was at the time.
We were all mystified. We had no idea why they were buying Shake. Why would they buy something that was such a small market, such a niche market, right? And so to this day, I still don't know why. I mean, but they did, and they also bought Chalice from Raise from RFX.
Yeah.
And so those were two possible viable node-based compositing systems that could compete with Nuke. So Nuke, despite it having very rough years with the D2 software and kind of like almost dying a number of times, kind of was saved by Apple
Yeah.
It was saved by Apple killing the competitors, right? And then and then when the Foundry finally, became independent and it became a truly independent product, then that's kind of was this seminal moment in time where there were no competitors, people were struggling to keep Shake working. Nuke was there. It finally was available as a commercial product, independent of Digital Domain, and
Yeah.
Nuke.
Literally.
Explosion.
Right.
Yeah.
And then I guess around this time you actually also left DD and you went off to work at places like Image Movers Digital, I think, and
Yep.
then eventually DreamWorks.
Yeah.
What were you doing at those different companies?
Well, I had by this time I had already been in visual effects for 15 years, and I was getting a little burnt out. So I decided to take a break and get married and have a family, that kind of thing. And Image Movers was a feature animation company started by Bob Zemeckis up in Northern California, and that seemed like a good out of visual effects, get into feature animation. And that was a learning experience because for this entire time I had been using Nuke in the context of visual effects and the way Digital Domain worked internally. I had never actually worked in another company. So working in feature animation, while it was very similar, had a whole different requirement of workflows. And it was a really an amazing learning experience, learning how feature animation differs from visual effects while still being the same. So I was still making tools very similar to visual effects, but extending it now to kind of fit within a feature animation idea. And then DreamWorks, Image Movers got shut down by Disney, and then I transitioned to working at DreamWorks to help them bring Nuke into DreamWorks as a third-party product and replace their in-house compositing.
Right.
Yeah.
With Nuke.
With Nuke, yeah.
Yeah. Hopefully
Yeah, so-
it was with Nuke.
With Nuke, yeah. So that was a lot of, so to make it work within a feature animation paradigm meant a lot of custom nodes, a lot of custom tailored workflows that fit feature animation best. Multi-shot compositing, being able to do algorithmic expressions with channels, subtractive color correction, those kinds of things that really suited lighting and shading in feature animation.
And you're now back at Foundry. What are you
First time.
What are you actually working on now, Jonathan?
Yeah, so I've been at Foundry now for a little over 4 years, and I'm working on the new 3D system. So I had written the original 3D system in the early 2000s, and by the time I left Digital Domain, it was already showing its age. And this was before Alembic, before USD. It was all designed, for a whole different paradigm. So the whole 2000s or 2010s went by with not a lot of change to the 3D system, and it really needed to be completely updated to work with modern file formats like USD, modern scale, the size of scenes now, and that's been my primary project. And then on the side has been working to bring more multi-shot functionality. Primarily for feature animation, but it turns out that a lot of visual effects companies are now doing more multi-shot types of work. So,
yeah, awesome. Well, I'm sure Foundry is so glad to have you there. And as you said, you're back for the first time to Foundry. I didn't mean that you'd been there before. Okay, I'm actually going to open it up to questions in a minute, but before we get there, I just want to do one quick thing up here. If you're a Nuke user, especially from the old days, there was a really fantastic site called Nukepedia. Still exists, but it's kind of been lost because of technical reasons. The forums are not operating as they should. But the team is getting it back together, and I thought you might be interested in scanning that QR code if you'd like and checking out Nukepedia. They're doing a survey just to find out what they think the Nuke users would like out of Nukepedia. So please go and do the survey, and also they're taking donations, but that link is to the survey. You've been interviewed on Nukepedia, I think, Jonathan, quite a number of years ago.
Yeah, Frank Ruder, who started Nukepedia, was at Digital Domain for many years. And so we knew each other. And he did that fairly early. Think about that. That was a long time ago.
Yeah.
2008 or 2009. So
Yeah.
it's been a while.
Great gizmos on there to download.
Great
as well.
gizmos,
Yeah.
plugins, yes.
Yeah.
It's a really good
Cool.
resource.
Okay, well, can we thank Jonathan just now for that amazing talk? Thank you, Jonathan.
You're welcome.
And I think I'm going to walk around with this microphone if anyone's got any questions, and I'm going to carry some magazines with me. So if you ask a good question... Okay, let me pick up these. Jonathan, are you ready for some crazy questions?
I am.
I'm going to start with
Do your
Paul
worst.
in the...
Well, thank you for a great conversation. I mean, for someone who started off as a flame artist back in the 90s, to see this and the progress is just amazing. And I wonder about the time of Titanic.
Mm-hmm.
You said that you moved into floating point later on.
Yep.
How did you handle the plates into compositing? Because I, at the time, worked on Cineon that linearized everything on a certain place in the script and then back out to log.
You probably don't want to know.
I do.
We did not properly de-log. We actually used a gamma curve to do a poor man's de-log. And
But you
I didn't
still
even
made
know
two
about this
billion.
until later. So it was all, because it was all done in video gamma, there was a grade node. The grade node started life at what was called Cinegrade, which is a separate tool that was used to convert the negatives, the log files, into which are essentially video gamma. And it was done with color correction. You know, somebody looked, okay, looks good, you know. That's how it was done.
Excellent.
Yeah.
Titanic still made pretty well at the box office. So
Yeah, it did. I'm just amazed whenever I watch the movie that you don't see 8-bit quantizing all over the place. I'm just amazed that we actually were able to pull it off.
Yeah, great question. Okay, come around here.
First, a small thing. How much regret do you have because you named it Nuke and now Googling Nuke compositing explosion? I think the CIA is on all of us because of that. And perhaps second, is there any tool or bug what took the most time to accomplish or perhaps fix in this tool? Do you have anything there? Or is it now your new 3D workflow that took some time to really get going?
Both 3D systems have taken a long time. But the name Nuke, yeah, I mean, we were sensitive when we went to productize it about that word and what it meant. But it was just felt it was a good name. And yeah, the Googling is a bit of a pain, and I'm sure that some governments have looked at it's like, what are these people doing? But yeah, the 3D system was a huge project at the beginning, and it's a huge project now. So it's not just a viewer, but it's geometry processing, it's rendering, it's importing and translating. It's just a huge. And at the beginning, because I had no experience in 3D, it was just trying to understand how to do something and using Houdini as kind of a template for, okay, this is something I can use. And the reason why, for example, the 3D system has those round nodes that you connect in one way, and the geometry nodes is the round nodes were from Flame, right? And that was, so I love the way Flame allowed you to easily do parenting hierarchies, and it was really easy, right? As an artist to, a non-3D artist to think about that. And then, but I wanted to do more complex geometry processing, and that's where Houdini. So that's really what drove that. And it took years. I mean, it took years to, like 5 or 6 years for really it to come to fruition. And then it's not taking quite that long for the new 3D system, but it's, doesn't happen overnight. It's a lot of work.
Looking forward to this system.
Yes.
For sure.
Hi, thank you for the great talk. You mentioned that at the beginning, Nuke was beginning as only a script, like document or language, and I don't know how Flame worked, but did you immediately, as you constructed Nuke, switch to nodes, or was there like some in between stuff, or?
This original script base was nodes, so you would type in. Like, I'm going to read an image, and then I'm going to blur it, and then I'm going to do a color correct to it, and then I'm going to merge it with this other. And you would basically build a node structure using the script.
So you would basically each node was like a function in this specific programming language. Okay,
exactly. I mean, it's like a shader graph, right? It's exactly like building a shader graph. Yeah, that's exactly what it came. And then when we had the UI. It was freeing. Yeah.
Okay. Thank you.
Hello. I've been using Nuke for about 15 years, and now I'm teaching it for the past 5. I have 2 questions. One is regarding the how many people from the original team that developed Nuke are still working on it, and second, what's the policy for maintaining backwards compatibility? Like, because there are certain things that I wish they were not there anymore.
Right. Well, I'm the only one. Bill Spitzak, who was the primary engineer, he went on to work at Rhythm and Hughes and DreamWorks and a few other places. He's working in Apple now. But yeah, I think I'm the only person from the original team. And I really wasn't on the team at Digital Domain. I was an artist and a supervisor and doing that in my spare time. So it was really Bill and 3 other people. So we had a very small team of people at Digital Domain who actually were working on Nuke full time, like maybe 3 people total, and then me in my spare time. And then about backwards compatibility, that's a hard one. In fact, we're wrestling with that all the time because there are nodes in there which are left over from the 90s and are still being compiled and kept up to date and working. There are some that are hidden that you don't even know about, but you can get to, like Bezier. And that's from Nuke 2. And that was replaced by the Rono node. So the problem that we have is that at some point you have to get rid of that stuff. It just becomes impossible to continue to maintain it. So we will have to be smart about removing features at some point. Backwards compatibility is great until you need to really make a new thing, like a new 3D system, for example, and you have to get rid of the old 3D system. So, yes, that's coming. That's coming.
Yeah, here. I'm probably the odd one out here in this group. I'm actually not on I got nothing to do with VFX. I'm a software engineer and actually developing a plugin for Nuke. So from my perspective, I'm curious about how the NDK evolved and might evolve.
So in Nuke 2, there was no NDK. All the nodes were compiled into the product, and you couldn't extend it. So Nuke 3 was the first time that we made the NDK public and you could write plugins. So it hasn't changed dramatically since the year 2000, to be honest with you. If you look at those main base classes, they're very, very similar to what they were 25 years ago. But we're doing, there's a lot of change happening now. We're pushing forward with a lot of changes and a lot of cleanups and trying to make the NDK more flexible because it's still, if people don't know, the library that the NDK is used to build plugins is still called DD-Image, Digital Domain Image Library. To this day, it's still called DD-Image. And so we're slowly modernizing it and getting rid of some of those digital domain-like features. And it's just a gradual process because to the backwards compatibility question. So if we change something in that NDK, it can break a bunch of plugins that people make out in the world. And so we want to be careful about how we do that. But we still want to push it forward.
Hello, thank you first of all for the great talk to both of you. And yeah, I got a simple question. Since you mentioned that you used cloning in the Titanic script, my question would be in 2025, is it safe to use cloning inside
It's
of
never been
Nuke?
safe to use clones. Even,
And maybe as a secondary question, is there any like other bug in Nuke that you maybe have there for many years and think that you should finally remove it?
Yeah, well, there are plenty of bugs still left over. What a lot of people don't realize is that because Nuke was an in-house production tool, a lot of the design, air quotes design of Nuke was just happenstance, or it was just what was best at the time. And what some things that may look like a bug are actually a feature, and some things that are a feature is actually a bug. And there's a good example in the 3D system where you take a card and then you split it into two and you transform it differently, then you merge it back together again, and you get two cards. That was never supposed to happen. That's actually a bug, but people started using that in production as a feature.
It's a useful
So,
one, yeah.
yeah, it's very useful, but that was never intended to work that way, right? So there are many other examples I can point to where I can say, well, that was never designed. That's just people just assume that somebody actually spent time designing it, and a lot of it was just what we needed now, throw something. And just a really quick thing about the UI. The UI back in the day was very, very simplistic and very, very clean. And that was because we didn't want Bill Spitzak and the other engineers to spend any time working to make the UI nice. It was a tool. It was a tool to get work done. It was not supposed to look nice. And that was a big change. So when Foundry took it over, they made a really nice update of the UI to make it look the way it is now. But we were never interested in that as artists. We were just worried about, we were concerned with getting our work done as efficiently as fast and having a fast tool.
Okay. Thank you, and I'll be careful with cloning then.
Thanks. Very interesting stuff. Great to hear. I've always been wondering the flow within Nuke, talking about the interface. Was it always meant to use it from top to bottom or from left to right? Or was there no...
There's, yeah. So originally, there was no snapping of the nodes. And so it was whatever you wanted it to be. There were some people who were used to Cineon who had very strong feelings about being left to right. But most of the people were top-down, organize it. But there are
Shake
artists,
was top to down, right?
yeah, it's just the fact that the words tend to be horizontal and stretch the nodes out in width, and vertically the nodes tend to be narrow and thin. So you just naturally try to stack them vertically. It's just because text tends to be like that. If they were all square, it wouldn't matter, right? Yeah. But they tend to be long and thin. But that's really the reason why. But there are artists who would make their Nuke scripts like a bird's nest. And where the right node was right in the middle. And all the nodes would go around, and the wires would be everywhere. And it would literally look like, you zoom out, and it would look like a bird's nest. And then Sony Prichard, who brought a certain Teutonic, she was German, and so she was like, I can't stand it. I need it to be lined up. And because as supervisors, we would take over scripts to help, and we were like, oh my God, So she was like, we have to have snapping. And so once you started to do snapping, so the nodes aligned with each other, you just kind of fell into a natural flow. And yeah, that's how that happened.
Thanks.
We do have time for one more question. Okay, here we go.
Hello, Jonathan.
Judith!
Really, I don't so much have a question as want to just emphasize how important the roots of Nuke were to come from a production environment.
Yeah.
As somebody who actually worked with it back when it was a TCL script and would pop up a viewport at the end.
She knows.
On Interview with the Vampire.
Yes.
I can speak to that. And then having it the foundations in a scripting language actually was where a lot of the strengths came from too. So as we were bringing data from the stages as motion control or maybe from track, one script could generate a Nuke script with the clones, with all of the 3D tiles, and equally generate an environment in Prisms, a precursor to Houdini, where actually you could see why your image was not going to be visible and if it was behind you. So the level of integration, the way in which it was pipelinable, all of those things I think came out of the fact that people like you were moving back and forth between development and being an artist, and people like me could say, well, make it do this tomorrow.
Yes, exactly.
Right? So it's been a remarkable piece of development, and remarkable how many of the concepts that were developed then are just as relevant, if not more, now. And I wish I had a question for you, but I really just wanted to say thanks for the blast from the past.
Yeah, no worries. And one of the things, some of the parts of the architecture of Nuke likely would not have made it into a commercial product that was designed as a commercial product from stage one, because they would have been either too complex or why does anyone need this kind of thing? Like why do they need 1,024 channels, right? To this day, it's still difficult to find packages that'll handle multiple channels very well. And that was a direct workflow need. And that's something that was very difficult to implement and is still kind of difficult to keep going. And it's something that if you come at it from a commercial standpoint, it's like, is that really going to help me sell my product? So some of the features came about exist solely because it came from an internal production pipeline.
I'm afraid we've run out of time, but can you please thank Jonathan Egstad?